Hello and welcome back to my shed. You may be wondering why I'm recording these in the shed now. Well, this is because this is my sanctuary. This is where I have all my toys, all my tools. This is where I bring out bearings, strip them down, inspect them, do the inspection and failure reports for our clients. Also, it's the furthest away from the house, so there's less chance of my children coming in the room and making noise and noise from the animals as well. So what we're going to do is today is we're going to Book of Gold case study number 2 of 6, which we're going to be going through. This is chapter 9 and it's case study number 12. Stage 4, rolling element defect due to EDM. So JPS reliability, what we mainly do, we enhance system reliability through condition monitoring technologies. Don't forget, condition monitoring does not improve reliability on its own, because you've got to take the technology and improve machine system uptime, its functionability, keep production running for longer. To do that, we need to determine the failure mechanisms in the asset and what their associated condition predictors will be. And once you know what a predictor is, what technologies can you use to detect those indications of failure? And we use all that to drive the maintenance of proactive tasks to ensure that production is kept running as sweet as possible. These here are the 6 case studies in this series we're doing with RMS. Today is case study number 2, as I said, chapter 9, case study 12 in that chapter, and it's stage 4 rolling element defects due to EDM. This is just a stock image of a generic pump set. So basically at this particular site, operations had noticed that the pump sets weren't sounding as normal. Bear in mind these have been in for a few years, 2, 3, 4 years, and they're on variable speed drives, and this is the first time the operators have noticed they sound bad. So as a gradual deterioration, they didn't really pick up the noise change till it goes really bad. So we were requested to perform vibration analysis to advise them the best course of action, and that's to remove any motors prior to any secondary damage, as they were both running with stage 4 damage. This is the vibration data here. So what we've got is a peak view spectrum from the non-drive end motor, and you can see a nice clear match the BPFO for the bearing on that particular motor. When we actually inspected that bearing, so we got the NU bearing, the out array signal, and what you can see here, these lines down there, that is the length of the rolling elements. So as the rolling elements are coming by, you got that discharge in the bearing. The top here, the balls, which we showed you earlier, these were frosted in colour and they had fatigue amazingly, and they've all started to crack and fatigue and come up. So this bearing's been in for a while. For motor 2, we had a lovely in array signal. You can see some sidebands now poking up around there, again from the bearing. And when we inspected that motor, there you can see in the race, this is the arc of the element. So here you have the ball come around and the arc is coming through. Beautiful defects, and they were clear stage 4 in the vibration data. So the findings from this little case study was, following on from the asset assessment, they were removed in a controlled manner, so it didn't affect production and hence the bottom line, and it was the correct decision as we could see the bearings were close to catastrophic failure. Motor 1, the non-drive end bearing, 6316, that had considerable spalling as we saw on the bearing I showed you, and the other bearing had EDM on it across the ball rollers. Motor 2 had indication of EDM on both the outer and inner bearing. So with variable speed drives, this shows you that not one motor is the same. Not one motor in the same plant duplicated are the same. There's so many variables in the installation and the incorrect installation of the earthing and the ground and the high frequencies, even back to the transformer. It's a big subject. So you must remember, always take each case as a new case. Don't think it's going to be the same as the other. Is chapter 9, section 12. With all of our case studies, we have sort of like a background, your findings, and then obviously the vibration data and stripped down images. So in this particular one here, the background was this was a process plant water pump motor. They had a variable speed drive on it for quite a few years, and obviously they didn't notice a change in pitches over the years, but one day they came in and it sounded quite bad. So we were called to do an asset assessment. So we did a vibration assessment and we said clear as day, high risk damage, stage 4, you got EDM damage from the high frequency switching on the drive going through the bearing. You'll see in the book we have some vibration data as a peak view data. We got the stripped down images, we got the failure mode, EDM damage. There's a roll there, you can see like a washboard effect, and because there's a roll there it's actually longer across, and these are the rolling elements which I was quite impressed with how fatigued they were. And on the second page, or third page sorry, we have another data. This is now showing us the inner race defect, and we have the lovely washboard pattern on the EDM. Now we actually have that bearing here, so what we'll do is I'll just quickly show you the bearing up close. So it's in 2 halves, cut them in half there, so it's a reasonable size bearing. And what was very nice was you can see on here the you know, it's sort of like a muscle sort of misty color, obviously as the current passing through, but this had been there for so long that it fatigued, and we got some lovely cracks there on all the elements there. Beautiful fatigue. So this is just age related fatigue. Obviously the driver behind it was EDM discharge through the bearings, so you can see there some lovely defects. We are seeing EDM defects a lot more lately. We'll do a few more videos on other case studies for EDM, but this was quite a simple one. So we went there, did assessment, we could tell what caused the defect, what the defect was, the bearing failure was, and now we're helping them to rectify so this doesn't happen again. And look, there you go, see. Well, I got you, I'll just go through one thing. I don't know if you know this. So when we're measuring bearing defects, we're sampling to pick up the period of the defect signal, of the signal from the bearing. So we're sampling, and if we sample fast enough we could pick it up. With most analyzers now we got the Peak View Plus, SBM HD enveloping as well. They sample super fast. I'm sure it's like 20-40 kilohertz. So we're broaching to like the ultrasound range. So the faster we sample, the sooner we'll pick up a defect. And just to get people's heads understanding, you know, where the defects will come from, if we look at this bearing here, I've put a line straight down there. So to work out an inner race defect, it's simple as the period of the defect signal passing the inner race and the rolling elements. So if we look there and we count how many rolling elements this imaginary defect will hit, so we've got 1, 2, 3, 4, and nearly 5. And I wrote down a defect, so this one is actually 4.9 orders. So that is how we pick it up there. Cage, as you would expect, is about 0.4 order. So to prove that, if we look at this mark on the cage and we see how far that mark on the cage goes around when we move the inner race for one revolution of the shaft. So as we move it around like this, there we are, that's one revolution of the shaft, and our cage is moved there, so like 0.4 orders. If we bring that back together, and we can do the same for the outer race, is for one revolution of the shaft, how many balls pass the imaginary defect on the outer race. So if we go there and we go 1, 2, 3 and a little bit, and the defect frequency for that is 3.04. So that's just a little visualization to help you understand. So when we pick up a bearing signal, it's not like a frequency, but it's a period we're picking up of a pulse of energy from a bearing. So as I said, this comes from the Book of Gold. This is the one there, which is here. Hardback, cloth foil, gold foiling on the front, dust jacket to keep it nice gloss inside so it can keep it clean, and a black ribbon for marking where it is, and nice clean end pages. It's a huge 338 pages and weighs 1.612 kilograms. What we're really pleased about is that what we decided to do is that the Book of Gold is going to be part of the public training material with Reliability Maintenance Solutions Limited. So if you go and sit their public course, you will get this. And the reason we feel the Book of Gold suits level 2 is because that's where you're doing analysis, and you've got to do analysis on defects and work out. So with this book, you've got a mass of case studies which will help you. Again, it's suitable for level 1 to level 4, even for reliability engineers who are doing root cause analysis to work out what's going wrong and what's the defect. On the other hand, we have our first book, Enhancing System Reliability for your vibration technology, which again, we decided with RMS that will be on level 3. That's because that's more of a technical book rather than this is more case studies. International stock is at the moment Reliability Maintenance Solutions, and we're just finalising Australasia, USA, Canada and EU for the Book of Gold. Thank you for listening, and keep an eye out, and we'll have some more videos coming through soon to finish off this series of 6. Take care. Bye.